Welcome back, 6th grade. Happy Monday, April 27th. We are in Unit 8 again this week, our new unit on the stars and the universe. Up to this point, hopefully you guys have started to study your vocabulary words on Quizlet. Those terms have been up there from last week. And at this point, if you're starting to feel good about studying those words, when you are ready, we're going to do the test section one more time, just like we did in the previous lesson. So if I think almost all of you got that figured out, no problem. So go ahead and do what you did before. Study using the different mechanisms, the different flashcard quiz features on Quizlet, or however you want to study your vocab words. And when you feel like you know those 13 words, you can go on and take the test section one time, and it'll show me your grade, and I'll put that in for your vocabulary quiz for this this unit, all right, or this chapter rather. Okay, and so we are going to continue talking about stars, and today we're going to be in section 8.1.2 talking about the life cycle of stars. And so you guys know that humans have a life cycle, animals, plants, there's life cycles that we witness from being born to different phases of life and dying, and stars are no different. They also change and have a life cycle much like many of the other things in God's creation. Except that stars' life cycles last a really long time. And so stars change, but they change so slowly over billions of years that we really don't see it. But they do, they're born, they mature, and they die much like the rest of God's creation. And so you may be wondering, since stars are so far away and we can't really go to a star, like how do astronomers know that stars change? How do they figure this out? Well, they have different tools, and the most common tool that's used is called the Hertzsprung-Russell diagram, named after those who discovered and utilized this tool first. It's also commonly just called the HR diagram, which is likely how I'll refer to it for the rest of this video, because Hertzsprung-Russell diagram is a mouthful to say. All right, and so the HR diagram is a graph that plots the relationship between the star's spectrum, which we talked about in the previous video, and the absolute magnitude. And so basically, it's a graph that plots the difference between the brightness and the temperature of a particular star. And those were two, absolute magnitude and spectrum are two vocabulary terms from the last section. So if you need to, please go back and make sure you're comfortable and understand what those two terms are. They're in bold in the previous section. Okay, and so on this graph, the temperature is marked along the x-axis, or the bottom of the graph, and the absolute magnitude, brightness, or sometimes called luminosity of the star, is on the y-axis, which runs the side of the chart. And this is an example of one of these HR diagrams here. Okay, so you see temperature in kelvins down here on the x, and the luminosity or brightness on the left side of this chart. Okay, and each one of these dots or circles of various colors and sizes represents a star on this chart. And we're going to talk about where stars fall along these lines. Okay? So if you need to refer back to that picture or look at the one in your book as we discuss kind of where stars go on this chart. So on the HR diagram, really hot blue stars end up in the left portion of the graph, while cool red stars are in the right portion. The brighter stars go at the top of the chart, and the dimmer stars go at the bottom of the chart. And there is a band of stars, if you go back and look, it says the main sequence, and we're going to talk about that in just a second, but there's a band of stars that seems to stretch from the top left to the bottom right, and it goes down the HR diagram, and that's the main sequence here, okay? See this band right here. Right? And we said the hot blue ones are up here. They're on the left, the red are on the right, and the brighter ones are up top, while the dimmer ones are on the bottom, okay? So, on the HR diagram, there's a diagonal pattern called the main sequence, which I just showed you. And during the majority of a star's life cycle, it's going to fall into the main sequence pattern. So we would find the majority of stars during the majority of their lifetime to be in that band or main sequence. As a star changes, it moves across this HR diagram. So as its life cycle goes on over billions of years, it's going to move across the HR diagram. Most stars, including our own sun, fall into that main sequence, okay? And I have some supplemental videos to show you after this to help this make more sense, and you'll actually get to see where our sun is plotted on the HR diagram. Okay? And now, okay, so we've talked about the HR diagram. Now we need to start talking about exactly what the life cycle of a star looks like. Where does it come from? How does it change over the course of its life? All right, and so stars are born in nebulae, and nebulae are just large clouds of interstellar material, things like dust, gas, and particles. And we call these stellar nurseries. So you guys know we have a nursery at church. That's where we put the little babies, right, in a nursery. So think of this as kind of like the nursery for stars. This is where they start out. They start out in the stellar nursery with the dust, gas, and particles. What happens is that these raw materials begin to cluster together. So the dust, the particles, and the gas, they begin to cluster together, and they begin to contract from its own gravity. So the gravity of all these things begins to contract, and it grows hotter and becomes more dense. And once it's hot enough at the center, nuclear fusion, or a nuclear reaction that we talked about briefly in a previous video, begins to happen. This happens at roughly 15 million degrees Celsius, so hot, okay? And as nuclear fusion begins, it turns hydrogen into helium, so hydrogen gas turns into helium gas, and a star is born, okay? And so, once the star's mass from all of what we just talked about is stabilized, the force of gravity maintains that star's size. And so at this point, most stars would belong on that main sequence of the HR diagram. This stage is the longest part in the star's life cycle. Okay, so that's key. So remember, if you're ever asked, where does the star spend most of its time in its life cycle, or where's the longest stretch for a star's life cycle, it's most likely the main sequence. And so a star's position in the main sequence during its prime is going to depend on the mass. Stars with a lower mass are going to be located on the lower right of the main sequence, and stars with a greater mass, or a bigger mass, are located on the upper left of the main sequence. And if you go back and look at that chart again, you can see that. As a star ages, most main sequence stars are going to move up and to the right of the HR diagram, excuse me. So they'll start and move up and to the right. It's probably reversed because of the camera, but you get the point. And as they do that, they become either giants or supergiants. So these are two types of stars, either a giant or a supergiant. A star at the end of its life cycle will eventually expand and cool as it runs out of hydrogen gas. And at this point, we call it a red giant. The star at this point, as a red giant, widens and becomes larger, cooler, and redder. Remember, blue is for more hot stars, so it's becoming a red giant now because it's becoming cooler and more red, because it's burning excess helium and running out of hydrogen gas. Okay. Eventually, average-sized stars lose their outer layer of gases and begin to eject materials. And so as they eject materials, this forms what's called a planetary nebula. Okay? And what remains after this is called a white dwarf. If you go back to that HR diagram, you'll actually see a little section there towards the bottom of the graph where it says white dwarf. And these are small, hot, faint stars at the end of its life. So this is towards the end of the life cycle of a star. And they fall into that left corner of the HR diagram. They're hot, but they're very dim. So they're still really hot because they're over on that side of the graph, but they're low on the graph because, remember, dim is on the bottom, bright are on the top. Okay, so if that was a lot of information right now, I get it. hang in there. I think the next video lesson will really help solidify some of those terms that we just talked about, because I know it's hard to conceptualize, but we're going to be looking at some pictures to show you the progress of all these different stars in the life cycle. So hang in there. And to close, this is what I would like you to do. One, there's no homework for this lesson. What I need you to do is go to the information below this video and watch the 2 videos that I have linked there. I found them to be very helpful to really understand the concept of the HR diagram and what a nebula is, or the stellar nursery that we talked about. So you can get a good idea of where stars come from and how astronomers use these HR graphs to determine where a star is in their life cycle. So watch that. It's not a super long video, but hang in there and watch it to the end. I promise it'll really help make this a little bit more clear to you. All right, and with that, I will see you on Wednesday for your next video lesson, where we will continue talking about the life cycle of the stars.